This is a responsive Power App that can be viewed on a desktop, a tablet, or a mobile device. And in this video series, I will show you how to build yours. This video is the third in my series on PowerApps Containers, layouts, and responsive design. And in the first two videos of this series, we learned the basics of the container control and went through how to use this container control to create modern app layouts. In this third video, we will learn how to take our new or existing Power App designs and make it responsive to fit whichever device is being used. And here's the cool part. I won't just teach you how to make this particular design responsive, but I will also explain the core principles of responsive Power App development so that you can take any of your own designs and make it responsive to fit whichever device. If you haven't watched the first two videos of this series, make sure to check them out. And with that being said, let's get into the video. I know, at long last, this guy finally released part 3 of the series. Jesus Christ. I was away in the last quarter of 2024, so I couldn't record new videos. But anyway, we're here. So let's learn how to make our own Power App designs responsive. I know you want to jump right into making this particular design responsive, but for you to truly master this skill and not just, copy what I'm doing, you would need to understand the key principles behind responsive Power App development. And I promise you that if you can take the time to learn these key principles, you will be able to take any design or layout and make it responsive no matter how complex. So let's get right into it. In a Canvas app, the user interface or UI is controlled by 3 main components. These 3 components work together to decide what you see when you are using your Power App. The first component is the device screen size and aspect ratio. This is the size of your screen at any moment, including the device orientation, whether it's portrait or it's landscape. The second component is the Canvas app code. This includes, all the controls and the power effects formulas that you've added to your app. It is basically the code that makes your app run. And the third component is the PowerApps engine. The PowerApps engine takes information from the first 2 components and then it checks the app settings and combines everything. It then uses this information to render the app UI on your device screen. And if even one of them is not set up correctly, it can affect how your app looks and works. Let's take a look at an example. If the device screen is a desktop and the app code is responsive, but the PowerApps engine has the aspect ratio locked, the app won't fill the screen like a responsive app should. Let's see another scenario. If the device screen is a mobile phone and the PowerApps engine allows responsiveness, but the app code is not responsive, the app will just look nasty.
Brother, what's that?
This is why it is important for you to configure all these 3 components properly. So for the rest of this video, we will tackle each of these components one by one. And by the end of the video, you will be able to make your own responsive Power Apps. So make sure to watch the entire video and don't just skip to the end.
You got me.
Let's start with the last component, which is the PowerApps engine. This one is the easiest to set up. All you need to do is to tell the engine that the Power App you're building is going to be responsive. So let's see how to do that. But before that, if you're enjoying this video or this series so far, please like the video and subscribe to the channel. Anyway, let's get back to our video. First, before opening PowerApps Studio, you need to choose tablets in the section where it asks if your app is for mobile or tablet. This is because PowerApps engine allows tablet apps to be made responsive for both mobile and desktop screens, but mobile apps can't do the same. Alright, so once you're inside PowerApps Studio, you need to go to the settings and then click the display tab. The next thing is to turn off scale to fit and turn off lock orientation. This basically tells the PowerApps engine to stretch the app to fill the available screen space and not limit it to one orientation. Finally, turn on the Show Mobile Notification Area setting. This setting controls whether your app leaves space for notification and time at the top of the screen. I recommend leaving this on since most phones have notches or front cameras that are about the size of this notification area. So if the setting is on, the app UI starts just below the notch. But if the setting is off, the app fills the entire screen. So bear in mind that part of your app might be cut off, or you can just add enough padding to make sure that the important part of your app is not cut off. Now, let's move on to the next component, the device size and aspect ratio. This one can be a bit tricky, and even I still make some mistakes. So I want you to pay close attention. If you've done any, front-end web development, you might have heard of the term breakpoints. If not, here is a simple explanation. Breakpoints are the specific screen widths where a website or app adjusts its layout to provide the best user experience. If that made sense to you, then great. You already understand how important this is to, making responsive apps. But if that didn't make sense to you, maybe I was just yapping, we'll look at a live example on the website now to make it clearer. I sometimes get comments, where do I get my app background images? So this is the website I mostly use, freepik.com. This is not an ad, by the way, but if Freepik is, somehow watching, I won't mind if you sponsor a segment. Anyway, the site has a free and a paid version, but I'm a cheap guy. I use the free version.
Brokey.
Let me show you how Breakpoints works by using the developer tools on this page. Right now, my screen is 1440 pixels, so everything is visible. Now, let's start reducing the width. Did you notice that? Once we go lower than 1096 pixels, the layout changed a bit. The top menu turns to a side menu, some fonts get smaller, and there are a bunch of other layout adjustments. Now let's reduce the width again. When we go lower than 768 pixels, we see another set of layout changes. At 640, another breakpoint occurs and the layout adjusts again. Finally, when we go below 480, we hit the last breakpoint and the layout changes one more time. As you can see, this website has 4 breakpoints: 480, 640, 768, and 1096. These breakpoints determine how the design adapts at different screen widths, ensuring that the app will look good on any device. Okay, let's get this HTML and CSS off my screen and let's go back to PowerApps.
Calm down, bro.
In PowerApps, Microsoft provides a default set of breakpoints to help with responsive design. To see them, select App and go to the Size Breakpoint property. By default, PowerApps has 3 breakpoints, which allow you to create up to 4 unique layouts. Here's how the default breakpoints are defined. If the screen size is less than 600, that is a mobile screen. If the screen size is greater than 600 but less than 900, that means it's a tablet held vertically. If the screen size is now greater than 900 but less than 1200, that means it's a tablet screen held horizontally. And finally, if the screen size is greater than 1200, that means this is a desktop screen. Now, in theory, you could build your app by manually querying these breakpoints. For example, you can say something like, if the screen width is between 600 and 900, show label. But if the screen width is between 900 and 1200, don't show label, and so on. However, doing this for every single control will make your app unnecessarily complex and slow. So to simplify this, what Microsoft did was to introduce a size property to each screen. This size property is a calculated value based on the screen's current width and the app breakpoint set on the app. The lowest value of this size property is 1, and with each breakpoint passed, this value increases by 1. For example, if the size of a screen is 3, that means it is between the second and the third breakpoint. Let's see how this works in practice. I've added a few text labels on the screen to help demonstrate it. The first label shows the current screen width. I've set its width to parent.width, and I've also set that as the text value so we can see it live. The second label lists the breakpoints from the app settings, and the third label displays the current screen size value. And to get the screen size value, just do the screen.size. So in my case, it's home screen.size. Now, in preview mode, let's test it. My screen width is currently higher than 1200, so the screen size is set to 4, extra large. If I reduce this width to 1050, the screen size changes to 3, and this is because it is now between the second and the third breakpoint. If I keep reducing this width, you would notice that the size value adjusts accordingly. PowerApps also has a screen size variable to make your app code readable. Instead of writing something like if home screen.size equal to 3, you can use if home screen.size equals to screen size dot large, and this value maps to this variable this variable maps to 4 values. So if it is small, that means the size is 1. If it is medium, that means the size is 2. If it is large, that means the size is 3. And if it is extra large, that means the size is 4. And here's another cool thing. The app breakpoint settings are fully customizable. So you can change a breakpoint, you can add a breakpoint. So for example here, let's change the breakpoint from 900 pixels to 800. And with these adjustments, a width of 850 would now fall between 800 and 1002, making the screen size to be 3 or screen size.large. Instead of it being part of the size 2 range that it was a second ago. And as I said, you can even add extra breakpoints. However, keep in mind that the screen size variable, it does not get additional values for this new breakpoints that you've added. So for instance, if you add a breakpoint of 1050, anything above 1050 will have a size value of 5. But the screen size variable will still only go up to extra large. At first I was wondering, why doesn't PowerApps just update this variable based on the new breakpoints? But then I thought, what would they even name it? If it is like 5, they can probably say something like extra large. But if it is 6 or 7, what would they even call it? Like mega ultra large. There's no way anything after that is not offensive. So I recommend sticking with the default breakpoints in PowerApps. But if you decide to change them, try to use breakpoints from popular frameworks. For example, Bootstrap's breakpoints are 576, 768, 992, 1200, and 1400. And that is a solid choice for most use cases. If that does not work for you, maybe if your client wants to use the Power App on their AI fridge or, I don't know, smart microwave, I wish you the best. Anyway, that's that for device screen size. The next component we are going to be looking at is the Canvas app code. And as you can imagine, even if the PowerApps engine and the device screen size has been fully configured, but the PowerApps code is bad, the final UI of the app will also be bad. So let's see how to develop responsive Canvas app code. To make your Canvas app code responsive, you need to follow just 2 simple rules. Again and again and again and again and
What is this? What is this?
Let's check the first rule. Rule 1. Every control size should be relative to the screen or a parent container. To understand this, let's see how controls behave on a responsive screen. I will duplicate this label, and for the first one, its width is set to parent the width, so it adapts to the screen. But for the second one, I would manually set its width to fill the screen. Now let's test it out. As the default screen size, everything seems fine. But when I set the canvas to fill the window, right away you notice that this new label does not stretch to fit or to fill the screen. When I reduce the canvas to the tablet size, the first label shrinks to fit the smaller screen, while the second one just stays there. Bro does not want to change. So next, I'll switch to the mobile view, and it's the same story. The first label fits, but the second one doesn't even show text because it has been cut off from the screen. What does this mean? For a responsive app, controls must size themselves relative to the screen or the available real estate. But here's the catch. Manually setting every control size relative to the screen would be a nightmare to manage. And this is where containers come in. If you watch part 2 of this series, and you should have if you haven't watched it, you'll remember that the first thing you should do on any screen is to add a root container. And this container will be set relative to the app screen. And then every child control inside it will adjust its size and its position based on this container. And one thing to note, you don't need to have only one root container. You can have multiple root containers. And this is for cases where your app has different layers. Maybe you have a layer for the pop-up and a layer for another pop-up, a layer for notifications, and then the main layer that contains the main screen controls. I will show you an example later. Anyway, that is that as for rule 1. Now for rule 2, use screen sizes and breakpoints to adjust control visibility and properties. Responsive apps are not just about resizing and repositioning controls, but creating an ideal user experience for every aspect ratio. This means that sometimes you need to hide a control, sometimes you need to show a control, or even adjust their properties. Let me show you how. Let's start with hiding and showing controls. I will reset the breakpoint to the default values first, and let's start. We'll pick one of these text boxes to use as an example, and let's pick America.
I go to America!
Let's say you want text box America to only appear on desktop screens. Here's what you do. First, you select all the relevant controls, and then in the visibility property, this is what you do. Set it to this formula, screen2.size equals to 4. What this does is that it makes these controls only visible if the screen size is equal to 4. And that means if the screen size or if the screen width is greater than the third breakpoint. So on the mobile view, you can't see this. You can't see the text boxes. On the tablet view, in both orientations, you still can't see them. But once you switch to the desktop view, they pop up.
America!
Now, what about controls? What about showing controls on only tablets? Let's use the Brazil text boxes in this case. I will set the visibility to screen size equal to screen2.size equal to 2 or screen2.size equal to 3. Now, on desktop, which is size 4, the Brazil text box is hidden. On the tablet view, whether it is the horizontal tablet view or the vertical tablet view, which is size 2 and 3, the Brazil text box appears. And on the mobile view, it vanishes again, except you rotate your phone to horizontal, where the size now becomes 2, and then Brazil text box is back. Now, visibility is not the only thing you can control with screen sizes. You can also adjust properties like font size, like padding, or even container direction. Let's take a few examples. For font size, you can use a switch statement like this. This adjusts the font size depending on the current screen size. And for padding, you can also set exactly how much padding you want on each device. For example, you can increase padding on desktop to improve usability and then reduce it on mobile to maximize space. You know, the possibilities are endless, and it all depends on the experience you want to create for your users and what you have in mind for the final UI. And that's that for role 2. Use screen sizes and breakpoints to control visibility and properties. Just remember, these breakpoints are dependent on whatever you've added in your app settings. So those are the 2 rules. Follow these 2 rules and you can easily make your PowerApps designs responsive no matter the complexity, even if your client wants to use it on their refrigerator. Jesus. Apart from those 2 rules, there's one more thing you need to keep in mind. Your app does not need to look perfect on every single screen size. Your main goal is to make the app functional and usable for your users. You know, focus on the important screen sizes. And if you're unsure, just ask your client. For example, I once worked with a client and the project was that they wanted the main device. The main device their users were going to be using the app was a tablet in vertical mode. So the app was meant for users or customers entering a physical store in Germany. And since the target device was clear, I knew exactly what screen size to focus on, and that saved me a lot of development time, and that is very important. If you're trying to make it look perfect on every screen, you know, you just waste a lot of time trying to make everything, you know, look good and perfect. So now don't go and misquote me and say Tolu Victor said I can ignore some screen sizes and then you go and completely neglect them. You know, always ask your clients, even if there is a small chance that your users will access an app on a specific device, make sure it is fully functional and fully usable, even if it's not picture perfect. A little hiccup here and there is fine, but if you leave the app completely broken on the screen, that's your own problem. For example, if you build a form and the submit button is not visible on mobile, you know, how do you expect your users to submit the data? If you keep on building apps like that, they will just fire you. No need for 1 month's notice or whatever. You know, just pack your bag and be going.
Do me a favor, please. Get out of here. Get out of here, man.
Now that we've covered the basics of responsive app development, it's time to put all of this knowledge into action. We will take everything we've learned from the full container series, part 1, part 2, and what we've learned now, and we'll apply it to our PowerApps design to make it fully responsive. If you've enjoyed this video or this series so far, whether it's the knowledge or the memes, please hit the like button. This series was originally planned to be a paid course, but I just thought, you know, just give away the knowledge for free as a YouTube series. So I will really appreciate it if you can like and subscribe so the video gets pushed out to other PowerApps developers like you. Also, if you want the PowerApps and data files from my videos, or if you simply want to support the channel, you know, you can join the channel or my Patreon as a member. So let's get back to our video. Now that we're back to our app, the first thing to do is to configure the PowerApps engine. So let's change the engine to make the app ready for responsiveness. So we'll turn off scale to fit. This tells PowerApps our app is going to be responsive, and we'll leave the show mobile device notification area on. This ensures the app starts below the notch so nothing gets cut off. As I said, this part is optional. You can also leave it off. And that's it. Simple, right? Let's go to the next step. Step 2 is to set the screen size and breakpoints. For this video, I think it's best let's stick to the default breakpoints to keep things straightforward. Maybe in a future video we can go crazy and do some custom breakpoints, but for now let's keep things simple. And one quick tip, I like to add a label to show the current screen size when I'm doing responsive PowerApps development. It's like really super handy for testing and development. So I'll add a text label here and set its text to display the screen size. Now let's check how the app looks with everything we've set up. On the default window size, everything looks great actually, you know, thanks to the proper layout setup we did from the start. The screen container is relative to the screen, and then all child controls are relative to that screen container. So the design fills the available space perfectly. That's great. On the horizontal tablet view, which is size 3, everything still looks awesome. You know, there is still enough space for all the elements. But then on the vertical tablet view, you know, things are starting to look squashed. And then on the mobile view, this is just nasty. So no worries, we'll fix it. And let's start with the menu. For mobile apps, the menus are usually one of 3 types. The first one is the pop-up menu. Basically, you tap an hamburger icon and the menu pops up. Simple as that. The second type is the bottom menu bar. All menu items are displayed at the bottom of the screen. And this is arguably the most common type of menu we see nowadays. And then the third one is the combination menu. This is basically a mix of the first two. They would have a bottom menu for key menu items like search or home, and then the side or the pop-up menu rather will have less frequently used menu items like maybe settings or profile. And this third method is perfect if you have like lots of menus or menu items rather. For example, the Twitter mobile app uses this brilliantly. On the bottom side, or the bottom menu rather, we have home, search, messages, notifications. You know, users usually use one of those menus every time they're on the app. And then on the pop-up menu, it has like less frequently used options like bookmarks, profiles, settings, and all of those. So in our case, we will go with a pop-up menu. So let's see how to develop that. I mentioned earlier in the video that when you are creating pop-ups in a responsive app, you need to layer your app, and each layer should still be in reference to the screen. Remember, we are building a responsive app. So let's see how to do all of that step by step. The first thing we will do is to create a new manual layout container, and I'll name it base root screen container. This container will serve as the root container for all my app layers. And since it's a manual layout container, I can place items over each other, hence the layering. Then I will clear the drop shadow and border radius from the container, and I'll make it fill the screen by setting X and Y to 0, and the width and the height to parent.width and parent.height. Now everything is set up, and everything on this screen will go inside of this root container. Next, let's move the existing screen container into this root container. So I'll cut it and paste it. Pro tip, before cutting anything, make sure to save your app, because if your browser just happens to crash at the point you cut out a section of your app, well, I don't need to tell you that you're cooked. You're definitely going to lose a bit of progress on your app. Let's just say I have some experiences.
It is what it is. It is what it is.
And anyway, once you've saved, cut the screen container and paste it into the base root container. And nice, that will serve as our root app container, or root app layer rather. Now let's create the pop-up menu layer. I will add a new manual layout container and call it pop-up menu container, and then I'll set it to fill the root container and clear the border radius and the drop shadow. Then I will copy the side menu from our screen container into this new root layer, into this new pop-up menu container. Cool. For now, I'll also hide the screen container so that we can focus on developing the pop-up menu so we don't get clashes. All right. So next, let's tweak the pop-up menu to make it a bit more functional. First, I'll set it to fill the height of the parents by setting height to parent.height. And then I want it to take 50% of the parent width when it is expanded. So I will adjust the width to parent.width times 6 times 80%. Next, I want a situation where if the users click outside of the expanded pop-up menu, the pop-up menu should close. So what we are going to do is to add a button they can click. So I'll add a button control and then set the button X and Y value to 0 and set its width and its height to parent.width and parent.height. This will make it fill the container. And I would also give it a black fill with 30% opacity, and make sure to apply the same fill for the hover fill property and the pressed fill property. Finally, I will add code to make it close the menu when the button is clicked. So I will just copy the code from the hamburger menu from the side menu component and paste it there. Now, let's test it out. It works as expected. I missed the text. Let's also clear that text. Great. Next, I want to modify the menu a bit for the mobile and the vertical tab view to properly maximize the space. What I want to do is to remove the logo and make the font sizes a little bigger. So in the side menu component, I will add a new property called app size. This will basically be the number variable that tracks the size of the screen. Then for the logo, I will set its visibility to this formula. This will make it so that the logo is only visible if the screen size is equal to 3 or 4. For the label font size, I'll also change it to this formula. And what this does is that for screen sizes 3 and 4, it will use the original font size formula. But then for screen size 1 and 2, it will use a flat size of 11.5. And I'll also apply these changes to the user name label. Great. So let's test it. As I switch the app size to 4, the logo and font size, they stay the same. But then if I change it to 2, the logo disappears and the font size increases. Nice. Next, let's now add this app size value on our 2 side menus. So I'm going to set the value to home screen.size. And remember, we have 2 menus, so we also need to set it there. And this will ensure that it automatically gets its size from the current screen. So let's test it again. On mobile and vertical tab, you can see the logo is hidden. And then on the horizontal tab view, the logo is now visible. And on the desktop view, the logo is still visible. I'll also remove the border radius from the button so we don't have the little border at the edges. Great. Next, we want this pop-up menu to only show when the menu is expanded and if the device size is less than or equal to 2, meaning if the device size is a vertical tablet or a mobile phone. So let's change the visibility to this formula. Var menu expanded is basically the variable that controls whether or not my menu is expanded. So that's why I've added it there. And then for the side menu container in the screen container, let's first make the screen container visible. And then for that side menu, I want that one to only show if the screen size is greater than or equal to 3. Meaning that if the screen size is horizontal tablet or the desktop screen size. Next, let's look at our final design. In the mobile app, we want a mobile menu where we can click to show the pop-up. So let's do that. We'll restructure the content a bit, just so we can do what we just said. Inside of the page content container, I will add a new vertical container and then just call it scrollable content container. So this is where all of our scrollable content will stay. And then I will move all the controls from the page content container into this new container. Then make sure to also clear border radius and clear the drop shadow. We don't need that for now. And next, I will adjust the padding. I want to move all the padding that is on the page content container and then move it to those child containers. So I remove the left and right padding from page content container and then add padding to the child containers. And this one, I want it to be 32 padding for screen size 3 and 4, and then 24 padding for screen size 1 and 2. I'll do that on the left and on the right. I'll also remove the top padding from the page content container and then add it to the header container. Then I also need to increase the height of the header container to match the padding we just added. Great. So I'll also add a gap of 10 and set the vertical overflow of the scrollable content container to scroll. As I said, this is going to be where our scrollable content is. And lastly, I will just remove the gap from the page content container. It might look like not much has changed, but this gives us way more customization options for our responsive design or for the responsive design we have in mind. Great. So let's create the static header for the smaller screens.
Okay, let's go.
What we'll do is to add a horizontal container, and we'll call it maybe static header container, and make sure to position it at the top. So I'll reorder it, and then clear the drop shadow, clear the border radius as usual, and then I want it to have a static height of 75. Next, I'm going to add padding. For the left and right, I'll match it to what we did earlier for the other child sections in the scrollable content container. And then for the top and bottom, this one is going to be a flat size of 5. And then inside of the container, I'm just going to add in the items. So it's going to be a hamburger menu or hamburger button to toggle the menu, a logo, and then a profile image. Then I will just size them and position them according to the basics we learned in part 1 of this series. I want the hamburger button to trigger the menu, so I also need to add that code there. Great. We are just basically going to be toggling our variable var menu expanded. Nice. It looks nice, but let's add a little bit more. I'm going to add a divider between the static header and the rest of the app, because on mobile you're going to be scrolling the scrollable content, so we need some sort of demarcation, and that's what I'm going to do. So the rectangle control, I'm going to add it, and then I'm going to size it and color it, so 1 pixel height, and then set the color to gray. And finally, I'm going to make the static header and divider only visible for size 1 and 2. So I'm going to set the visibility now. And then the original header, I want to hide it, but only show that one if the screen size is 3 or 4. Great. So let's test everything out now. On mobile, the menu pops up, the pop-up menu opens and closes perfectly. That's great. On the vertical tablet, it works as well. You notice that the menu, the logo doesn't show, the font size is a little bit bigger. And now when we move to the horizontal tablet view, the logo pops up, the font size is a little bit smaller. And then for the desktop, same thing. The original collapsible side menu is still there and it looks great.
I tell you what though, folks, that's bloody nice. That is bloody lovely.
With that, the menu is done and dusted. So let's move to the dashboard. So far, we focused on showing and hiding controls based on screen size. Now it's time to talk about resizing and repositioning them. And let me tell you, the magic here lies in the wrap property of the container control. This property does most of the heavy lifting for responsive app design. And what it does is pretty straightforward. It simply moves items to the next line when there isn't enough space on the current line. And that's it. Let's break it down with an example. On this page, I have a vertical container, and inside it is a horizontal container with 4 labels. Each label has a static height of 100 and a minimum width of 200, and the flexible width is on. Now, without wrap, when the screen size is too small, the app either adds a scroll bar or just cuts off the labels. But with wrap, the labels move to the next line when there is no more space. But the thing is, simply turning on wrap doesn't rearrange the controls in the ideal way for your specific view. For example, for the tablet view here, I wanted 2 lines with 2 labels per line. And the app correctly splits them into 2 lines. Great for them. However, it gets the number of items per line wrong. We have 3 and 1. For the mobile view, I want 4 lines with 1 label per line. Here, it moves them correctly. But then, the parent container does not stretch to fit the items, which is what I wanted. So, what's the solution in this case? To get the wrap property working perfectly, you need to do these 3 things. 1. Set the width of your items. 2. Set the height of your items. And 3. Set the height of the parent container. That's it. So let's go step by step. We'll start with the width of items. When setting item widths, you need to consider padding and gaps between the items. And here's how to do this. I would use this formula for the item width. Here, for size 3 and 4, on the desktop and horizontal tablet, I will stick with the original minimum width of 200. However, for size 2, which is the vertical tablet, first I will take the available space, pairing the width, and then I will subtract the left and right padding, then also subtract the gap. In this case, there is only one gap, so I'm multiplying it by 1. But if it's 2 gap, you have to multiply it by 2. If you don't have gap, you just remove it completely. And lastly, I'm going to divide the remaining space by 2. And this is because I want 2 items per line. If you want 3, divide it by 3. If you want 4, divide it by 4. Simple. This ensures that no matter the screen size, as long as the size, no matter the screen width rather, as long as the screen size is 2, it will always get 2 items per line. And then for size 1, which is the mobile, I'm just going to assign all the available space to each item. So there is only 1 item per line. I don't need to divide anything. And since only 1 item, there is no horizontal gap. So that's why I've cleared the gap. So that's that as for setting the item width. Let's go to the next step, setting the height of items. For the item height, you might need to tweak it based on your design preferences. In some cases, you want to increase the height or decrease the height. So you query the screen size. Well, for this example, I'm just going to leave it at 100. Then lastly, which is step 3, we need to set the height of the parent container. And there are 2 scenarios for this one. The first one is a basic scenario. If you want it to have a static height, like no matter the screen size, the height should always be the same size, right? You just need to make sure to add a scroll bar by setting the vertical overflow to scroll. And that will enable them to access all the individual controls or child items, rather, of the parent container. But then, if you want it to have dynamic height based on the height of the wrapped items, you need to dynamically get this new height. Let's do it for this one. For size 1, the height will be the height of all the 4 items, right? And we are going to also include the gaps and the top padding and bottom padding, right? So there will be 4 rows of items. That means we'll have 3 gaps. Nice. For size 2, the height will be the height of just 2 items because, we want 2 items per line and there are 4 items, right? So obviously we will also add the gap, but this one there's only 1 gap. And then the top padding and the bottom padding. Nice. And then for the other sizes, it will just use the original height of 250. And let's test that. For the mobile, the container stretches to accommodate the 4 lines. You can see all of them stacked on top of each other. And then for the vertical tab, which is size 2, it separates into 2 lines. Great. And then for size 4, or size 3 and 4 rather, it's still 1 line, as we had it earlier. So now we know how the wrap function works. Let's apply it to our own app. We will start with the overview container. I want this section of the app to always have the same structure, the 2 lines stacked on top of each other. First line is the name of the section and the second line is content of the section. So line 1 and 2 on top of each other. The height might change, but the layout will always be consistent. Great. So let's go to line 1 now. Line 1 is just 1 label and a fixed height of 40. And that will be the same across all screen sizes. So we don't need to make any changes there. So we'll leave that as it is. Now for line 2, this is where we actually need to do a bit of work. The goal is to make the left container take up 1 full row and then the gallery take up the next full row if the screen size is equal to 1 or 2, meaning if it's like a mobile or a vertical tab. So what we'll do first is to turn on wrap for line 2. One thing to note though, when wrap is on, it uses the minimum height if any of the child items have their vertical alignment set to stretch. In our case, both items are set to stretch, so the wrap will just apply their minimum height as their height. So that's why the thing does shrunk like that. So to see what we are developing, I'm just going to give it a temporary height of 215. All right, great. So let's go to the individual sections. And as I said earlier, the three criteria for wrap to work well is 1, set the item width, 2, set the item height, and 3, set the parent height. So for the item width, I'm just going to use this formula to make the left container fill one row for size 1 and 2. And I'm also going to do the same thing for the right gallery. I also want it to take up one full row. It's the same logic we applied earlier. Great. So now for the item height, let's do the left container first. It contains 3 static height items, right? And I want the height to match the total height of all child items. So I want it to just be enough for the 3 child items. So I'll also include padding here. So I'm going to add this formula. Great. And in this case, there is no gap to include since the print container has gap set to 0. So yeah, that's the item height for the left side. Next, let's just do some other adjustments. For line 2, I'm going to give it a temporary height of 450 and then give the overview container also a temporary height of 500. I just want to be able to see everything we are building. All right, let's test it. Good, it's looking all right, but we need to tweak a few things obviously. First, let's reduce the font size of the task counter for size 1 and 2. I want it to be 18 if the screen size is equal to 1 and 2. Great. And then for the button visibility, I want to hide the new inspection button for size 1 and for size 2. Next, let's do some other padding adjustments. For the left container, for size 1 and 2 now, I want the top and bottom padding to reduce from 30 to 10. And then for the left and right, I want the padding to reduce from 20 to 10. You know, it's a mobile and tablet view. We need to maximize our space. So that's how I'm reducing the padding. Then for line 2, if the screen size is 1 or 2, I'm going to add 10 for the top and bottom padding. And then I'll keep it at 0 otherwise. And let's test it again. Great. Notice this small gap beside the view all button. This happens because the container still includes a gap of 10, even though the first control is hidden. So I meant to actually show this. So let's fix it. So to fix it, just remove the gap if the screen size is 1 or 2. Nice. So that's much better. So that finishes the left side. Let's move to the right side. For the right side, unlike the left side, where the height was the addition of the height of all the child items, here we're going to take another approach. We will set the height directly and then let the child controls adjust to fit the available height. So I'm going to use this formula. If the screen size is equal to 1, you should use a height of 215. If the screen size is equal to 2, you should use a size of 250. And then if the size is greater than that, so if it's 3 or 4, it should use a size or height of 215 also. Great. So let's move to the gallery. Inside of the gallery, first, I'm just going to hide the button and icon for screen size 3 and 4. And then for size 1 and 2, since we've hidden the button, we need to make the whole card clickable. So what we're going to do is to add a transparent button, and we'll make it take its positional properties from the root container. So the X value, the Y value, width and height, take that from the container, and then make sure this button is only visible for screen size 1 and screen size 2. Great. Now let's make the gallery break into 2 lines for screen size 1 and 2. What we're going to do is to increase the wrap count to 2 for those sizes. Next, we also need to change the template size since we've now increased the wrap count. So what I will do is to change the template size property. The former template size property, or formula rather, it was dividing the total available width into 4 equal parts. So self-item.count. So there were 4. So dividing it into 4 equal parts. But now I want to just divide it by 2. So yeah, let's do that. I'm also subtracting 1 because I want to avoid the scroll bars caused by rounding up of the numbers. Great. So now let's add a left spacing to the root container for screen size 1 and 2. So I'm just going to change the X value. This is just to make sure that everything aligns properly with the left container when it's stacked on top of each other. Great. So let's also adjust the card title height. I want it to be so if the screen size is equal to 2, the height should be 25. but then for other sizes, let the height be equal to 50. Nice. And then the last thing, let's just set the vertical alignment of the root container to center, because you know we've set the height of the parent container already, so we just want the items to just take the available space. So that is what we're doing there. Great. Now we are done with the left and the right side. We are going to set the height of their parent, which is line 2. So first of all, I'm going to turn off the flexible width and then set the height to this formula. Great. So what we are doing here is we are adding the padding, so the top and bottom padding, right, to only the left container's height if the screen size is equal to 3 or 4. So you know, when the screen size is larger, the left side and the right side take only one. So you only need to add the height once. Now, but for screen size 1 and 2, we need to add the height of both the left side and the right side, since they are going to be stacked on top of each other. So let's do that. So that's what this is doing actually. Also, let's set the height of the overview container, which is the parent container, to line 1 height plus line 2 height plus the padding. So this will make sure that everything is dynamically set depending on the size of the screen. So let's test it out again. I missed the bottom padding. Let's add that. Great. So let's test it. This is the view for mobile, looks great. This is the view for vertical tab, looks great. Horizontal tab also looks great. And then for desktop, nice.
Nice.
So far, I've only shown 2 ways to set height for responsive design. So for the left side of the overview container, we used a dynamic height based on 3 static height child items. For the right side, we used a static height and then just let the child items adjust to fit the available height. So for this last section, we'll see how we can set dynamic height when the child items already have flexible height. So for section 3, it has a minimum height of 350, and then its 2 child items are set to stretch. So let's see how to set this up for responsive design. First, turn on wrap for section 3 container. And let's also set the temporary height for task section and inspection section to 350, you know, so we can see everything we are developing. Now, let's set the item width. So for smaller screens, I want both containers to take up 1 full row. So I'm just going to use the same formula we've been using earlier. Great. So that's step 1. We've set the item width. Now for step 2, we need to set the item height. And this part is actually the tricky part, because even I thought I fully understood it, but when I was doing test runs for this video, I was making some dumb mistakes.
Ironic.
So here's the thing. When you want to make a section responsive and its child items already have flexible heights, you need to decide which one of these child items will ultimately control the height of the section. In this case, is the galleries that will control the height. So for the task section, is the task gallery that will control the height of the whole section. For the inspection section, is the inspection gallery that will control the height of that whole section. So in a nutshell, I want each section to stretch to fit the items that are inside the gallery. Got that? Great. Now, both galleries list the first 14 items in the table, but that will be too much for smaller screens. So what I will do is that for smaller screens, we are going to set it to show only the first 7 rows instead of 14. So I'm going to do that for screen size 1 and 2, and that's this formula. Now let's also do the following changes for a smaller screen. Now I want to avoid horizontal scrolling, so I'm just going to hide the table header, and then I'm going to reduce the amount of columns shown. So for the gallery contents, I want only the icon, the category icon, the subject texts, and the button to show. So that means I'm going to hide every other thing. So let's start with the category column. I'm going to reduce the width from 150 to 40, and then I will hide the category text, the location text, and the due date text for the bigger screen sizes. Nice. So for the gallery title, which is a label and the button, I'm simply going to reduce the label's minimum width from 150 to 100. And then for the button container, I'm going to give it a static width of 140. Nice. So let's see what we have so far.
Not bad, not bad.
Now we are done with those configurations. Let's go back to setting the height of the items. The idea here is that for smaller screens, I want the gallery to just have enough height for its items, and then the table container, which is its parent, will get its height directly from the height of the gallery, and then the gallery container will get its height from the table data container, and then the task section, which is also that one's parent, will get its height from the gallery container and the gallery title container. Great. And once we replicate that for the inspection section side, section 3 will then basically be the height of both sections. But then if the screen size is size 3 or size 4, it will just remain as is using its flexible height and minimum height of 350 and all of this. So let's implement all of that. Now for the gallery, I'm going to give it a static height, and I'm setting that to this formula: self the all items count times self the template height. So this is basically making the height just enough for the items. Great. So now we've increased the height of the gallery, we won't be able to scroll because the gallery's height is now larger or longer. It's just being cut out by the container. So we can obviously set the gallery's height to return back to normal for screen size 3 and 4. But I think for this case, it will be better if we just leave the height as is, because the height of the whole section will be dependent on the height of this gallery. So I'm not that comfortable with making it switch so much. All right. So for size 3 and 4, I want the table data container to have flexible height, and then we can leave the minimum height of 100. That's great. But then for size 1 and 2, it should have a static height, and then the height of the gallery will be what's controlling it. So we are going to set it to the height of the gallery plus its own padding. Now, flexible height is actually controlled by the fill portions property. So if fill portion is equal to 0, that means flexible height is off. But then if the fill portion is greater than 0, that means the flexible height is on. Now, what we'll then do is to just toggle it between 1 and 0 depending on the screen size. Also, I'm going to add a scroll bar to that container by setting vertical overflow to scroll, and this will then allow us to scroll through the gallery. We need to offset the width of that little scroll bar in the header for smaller screens and larger screens. Actually, we are going to increase the table header's right padding from 10 to 23, and then I'm also going to reduce the button column width from 50 to 30. All right, great. So now let's set the height of the remaining containers. The process will be similar to what we just did for the table data container. So for the gallery container, for size 3 and size 4, it will have flexible height turned on, and it will have a minimum height of 100. That's great. Then for size 1 and 2, it should then have a static height based on the table container, which is the direct child. Nice. So then for the task section container, this one is just a little bit different. For size 3 and 4, the vertical alignment should be stretched, right? So it does take all the available space in the parent. But then for size 1 and 2, I'm going to set it to start because we want to give it a static height. Then for size 3 and 4, the minimum height will just be parents.height minus the padding, right? So this will make sure it always stretches to fill the parent. We'll set it this way because this one is stretch actually, and since the parent container has the wrap property turned on, we obviously need to consider that when we're setting the height. Now, so that's that for size 3 and 4. Then for size 1 and for size 2, we are going to give it a static height based on the gallery container, the title container, and the padding. So we're just going to add all of that together. Nice. So let's just duplicate all of that for all we've done for the task section container, for the inspection section container. The only difference now is that the gallery here can also be displayed on smaller screens, since it's just two lines on top of each other. So all I need to do is just to reduce the number of records and set the height of the different child items to be dependent on that gallery.
One eternity later.
Once all of that is done, all we need to do is to set the height of section 3 container to be dependent on the screen size and the height of the child items. So for screen size 3 and for screen size 4, we're going to leave the flexible height turned on and give it a minimum height of 350. You know, that's how it was before. We're going to leave it as is. Then for size 1 and for size 2, we need to change it a bit. For the static height would then be based on the task section and the inspection section. And if you have padding, make sure you add padding, add the padding to it. So let's test it out now. On the desktop view, you can see everything is working how it was before. We have the collapsible side menu, we have the dashboards, we have the task section and inspection section. Everything is fine. On the horizontal tablet view, it's still very similar since there is still enough real estate. And then for the vertical tablet view, now the structure has changed based on all we've developed so far in this app. The collapsible menu has now become a pop-up menu. The menu dashboard is now split into two lines, right? And the inspection section and task section, they stack on top of each other rather than side by side, and they list only 7 items. For the mobile view, you can see it also has a pop-up menu. Inside the card, the height has been increased rather, and you can see basically how the rest of the app has arranged to fit the available real estate. So yeah, that is that as for this responsive design.
I like it a lot.
So before we wrap up this video, let's quickly talk about forms. Most Power Apps need some sort of form or data entry, so we'll always need a form on our app. If you're using a manual form, you know, the one where you manually add the text labels, the inputs, combo boxes, whatever, and you patch it manually to a data source, you can basically just apply everything we've learned so far in this series to make it responsive. But if you're using the form control, Microsoft has made our job easier since it has made it responsive by default. So the form control contains data cards, and then these data cards stretch in height to fit the items inside. Inside each data card, we have controls like the field label, the inputs, and then the error message label. And all of these are automatically positioned relative to each other. The labels typically start at 10, and then the inputs, which is directly under it, is dependent on the height of the label and the position of the label. And then the error message, which is directly under the input, is then dependent on the input size and position. So all of them are connected to each other. And then for the width of these controls, all of these are set relative to the data card's width, which in turn is managed by the data card properties and the form properties. So you can see by default, everything is set out to be responsive. So now if you want to tweak it a bit to ensure the exact sort of responsiveness you want for your app, what you need to do is to turn on width fits for each data card. Then you can set the width of the data cards in the form control properties. But if you want like a custom width for each data card, you can also set it manually. And so for example, let's say you want to make it take half row, you can set its width to parent dot width divided by 2. And you can even have, you know, different width for different screen sizes. Basically all we've learned in this video so far, you can apply that to that width property. And lastly, you want to make sure that the form control is inside a container, so it's getting its width and height relative to the screen or to a container, right? And then just make sure its width and height is controlled by that parent container. I think that's about it. If you want to learn more about building modern looking forms, I already have a dedicated video on this topic, so make sure to check it out if you're interested.
Okay.
And that brings us to the end of this video series on PowerApps Containers, layout, and responsive design. I sincerely hope I've done justice to this topic. So on a scale of 1 to 10, let me know in the comments what you will rate this series. For the next video, I have something really cool and unique planned, so make sure to subscribe and turn on post notifications to know when the video will be live. Anyway, if you enjoyed this series or this video, or at least learned something, please hit the like button, subscribe to the channel, and follow me on LinkedIn. Thanks for watching. Catch you in the next one.